So, we all thought that by now we would know everything about 3I Atlas as it's getting closer and closer to us. But scientists' guesses still seem to be as good as ours because we just got some massive updates that make everything too weird again. First, new telescope data reveals the object is glowing green, despite previous observations showing the object is missing the molecules needed to be green, and despite getting farther and farther away from the sun. Also, the tail pointing toward the sun is still there, clear as day, which seems to destroy the explanation scientists have been using for decades. In this video, I'll break down what is actually happening with 3I Atlas as it's getting to its closest point to Earth. But let's first start with the color. The famous Gemini North telescope in Hawaii just captured new images of 3I Atlas, and the object is once again glowing green. Now, the color in itself is not that weird. A lot of comets glow green when they get close to the sun. But as comets get farther away from the sun, they receive less solar energy. Less energy means less heating, and less heating means less ice turning into gas, which means the comet's color brightness gets weaker. This is one of the most predictable things in astronomy, but 3I Atlas seems to be doing the exact opposite. It passed closest to the sun almost 2 months ago. Since then, it has been moving farther and farther away from the sun. So, the green glow should be fading, not getting stronger. Now, this is very weird, but I do have a theory for what's happening here. It's called thermal lag. Here's how this would work. When 3I Atlas passed closest to the sun, the surface got blasted with intense heat immediately. But that heat does not instantly penetrate deep into the interior. It takes time, days, weeks, maybe even months, depending on how thick and insulated the outer layers are. Just like steak keeps slightly cooking inside after you take it off the grill. The outside might be cooling down, but the inside is still heating up. This delayed heating would be cracking open deeper ice layers that were frozen solid for billions of years, and those fresh interior layers would be loaded with carbon that is now sublimating into gas and creating the green glow we are seeing. But here's another very weird thing about the color. To create the green glow, you need carbon molecules floating in the gas cloud around the comet. When sunlight hits these carbon molecules, they glow green. But a while back, multiple telescopes ran the most detailed observations ever done on an interstellar object, and both the University of Hawaii and the MDM Observatory found something pretty shocking. 3I Atlas had barely detectable carbon molecules. Scientists looked for the standard carbon signatures that show up in basically every active comet we have studied. One scientific paper placed 3I Atlas among the most carbon-depleted comets ever known. Finding a comet this depleted in carbon is kind of like finding ocean water with no salt. But now, after 3I Atlas passed closest to the sun on October 30th, the carbon molecules are suddenly appearing. The green glow is visible in the new images. Carbon is there. So where did it come from? Well, I think the reason for this is something called cosmic ray processing. Let me explain what cosmic rays actually are. Despite the name, they are not rays at all. They are tiny particles, mostly protons, flying through space at 99.9% the speed of light. These things are getting shot out by supernova explosions all across the galaxy. If an object is floating alone in interstellar space with no planet or star to protect it, then it is getting absolutely hammered by these particles constantly. That is what happened to 3I Atlas for billions of years. This bombardment doesn't just hit the surface, it punches deep into the comet, going down 15 to 20 meters. At those depths, the cosmic rays are breaking apart molecules and rearranging them into completely different chemicals. Laboratory experiments on Earth have proven this happens reliably. After about 500 million years of exposure, pretty much all the original carbon monoxide near the surface has been converted. So the theory is that the outer crust of 3I Atlas had its carbon destroyed or altered into forms that telescopes cannot detect. But when 3I Atlas passed super close to the sun and got blasted with intense heat, that outer crust either blew away or cracked open like an eggshell. Now we are seeing deeper material, stuff that was protected for billions of years, which has normal carbon chemistry. Now, before we talk about the next update, I want to note that scientists have different theories about 3I Atlas. This whole situation makes us wonder, do we just accept what people tell us, or do we learn to analyze data and form our own conclusions? That's why I've decided to partner up with our sponsor, Brilliant. Brilliant is an interactive learning platform that helps you excel in technology, math, logical reasoning, and science. They don't just lecture you, they make you work through problems until concepts actually click. I've been going through their scientific thinking course, and it is perfect for learning how to spot bias in studies. You can try thousands of lessons for free, and my viewers get 20% off an annual premium subscription at brilliant.org. Josh Sullivan Space. New data reveals that 3I Atlas is still showing an anti-tail as it's getting closer and closer to Earth. As you probably know, 3I Atlas has this tail that points toward the Sun. We call this an anti-tail, and we've been seeing it for months now. Loeb came up with a very interesting theory that almost every scientist disagrees with. The idea is that 3I Atlas might not be traveling alone. It might be surrounded by smaller fragments or pieces that broke off from the main body. Here is how this would work. 3I Atlas is shooting out gas jets that act like tiny rocket engines, pushing it slightly away from the Sun. But if there are fragments floating around it that are not producing their own jets, those fragments would just follow pure gravity. Over time, the main object keeps getting nudged away from the Sun while the fragments keep drifting toward the Sun because gravity is pulling them. Even though the difference is tiny at first, over weeks and months that separation adds up. Loeb did the math and calculated exactly where those fragments should be by now. He figured out that if fragments separated back on October 29th, then by November 30th, they should have drifted about 60,000 kilometers or closer to the Sun than the main nucleus. The Hubble image released on December 4th shows an anti-tail extension of right about 60,000 kilometers toward the Sun. Loeb published his calculation before NASA released the image. If the swarm hypothesis is correct, then this Hubble image just gave us the closest thing to the first visual proof. If there really is a cloud of fragments surrounding 3I Atlas, then the combined surface area could be way larger than just the main nucleus alone. More surface area means more ice can turn into gas. This would finally explain why 3I Atlas appears so bright for its size and why it seems to be losing way more mass than should be physically possible for a single intact object. If you watched to the end, let me know your thoughts and theories down in the comments. Also, please drop me a like and have a blessed day. Jesus Christ is King.